I have lumped 5.5 and 5.6 together because they're both pretty small. So this first one, identifying chords, secants, and tangents. So you guys already know this is a radius, and this is a diameter, and this is a chord. A secant line is just a chord that's not a segment. So a chord is a segment that has a starting point and an ending point on the circle. A secant line is just a line that passes through the circle and does not touch the center. And then a tangent line is a line that touches a circle but only in one place. So a line that is tangent to a circle will always create a right angle with a radius that shares that point. And that's going to be important today. So here you just need to name the appropriate figure. So here we have two tangent lines. CD and CE are both tangent to the circle. We know that OD is 8.1, so that's the radius. And we know that CE is 10.8. Find OC. So if this is a tangent line and this is a tangent line, then both of these are right angles. And because these are both radii, that would be 8.1. Right? So this side is shared, and that is the hypotenuse of a right triangle. So 8.1 squared plus 10.8 squared is equal to C squared. So 8.1 squared plus 10.8 squared gives me 182.25 equals C squared. So take the square root, and I get 13.5. So OC is 13.5. And you'll notice in this construction that these two triangles are congruent. 8.1 equals 8.1, right angle equals right angle, and then this side is equal to itself. So if necessary, we could have said that that side is 10.8. And that will always be true of tangent lines. Okay. Let's do another one. All right, so OJ is 6. So this length is 6, and this length is 4.8. So this length is also 4.8, and that is a right triangle, and I want that length there. So a squared plus 4.8 squared equals 6 squared. So we'll just subtract 4.8 squared. So 6 squared minus 4.8 squared. A squared is 12.96. Take the square root, and I get 3.6. All right. So the circle below has center J. The measure of arc KL is 138, and KM is tangent to the circle. So arc KL is 138. So how big would angle LJK be? It's also 138 because it's a central angle. What if it was an inscribed angle? What would that angle be? Half of 138. So angle, this angle here, LJK is 138. it wants to know how big is LKM. So how big is this angle here? That's kind of hard to see. How big is this angle? Well, because this is a tangent line, I know that is 90. So this angle here has to be less than 90. And this one is 138. And those are both radii. So what can you tell me about this angle and this angle? They have to be the same size because the two sides of that triangle are congruent. So how do we figure out how big those are? So let me draw a bigger version of that triangle. If this is 138, and I know those are the same size, how do I figure out their measure? No. So this angle equals 90. Good. Yeah. So I know the whole triangle is 180. So if we subtract 138 from that, we get 42. So I know there are 42 degrees remaining. And I know that this angle is equal to this angle. So we just cut that in half, and both of those are 21. Okay. So LKM and KJL. So KJL is 138. And now I want to know how big this angle is. Well, if that is 90 and this is 21, then all we need to do is 21 or 90 minus 21, and we get 69 degrees. Let's do another one of those. All right. So here we have radius, radius, and that's a right angle. Arc DE is 66. So this arc here is 66 degrees. DF is tangent. Find EDF and DCE. So EDF, I want this angle here. And DCE is this angle. Well, DCE is easy. It's just 66. Okay. Let me draw a bigger version of this triangle. And I want this angle here. So this is 66, but I know that that angle, or that side and that side are equal. So if I take 180 and minus 66, I get 114. What does the 114 tell me? That's how much the remaining two angles add up to. And we know that those two angles are equal, so we just divide it by 2, and we get 57 and 57. And then this is a right angle, so the one angle I'm missing is just 90 minus 57, we get 33. Do you need to see another one of those? One more? Okay. All right, KL is 76, which means this is 76. So how big are these two angles? Would be 180 minus 76, which is 104. And those two angles are equal, so they're each 52. And if this angle is 52, I'm assuming it wants LKM, yep. So that angle right there is just 90 minus 52, which is 38. Got it? All right. So I know that this is a right angle because HI is tangent. Okay. And the segment KI passes through the center of the circle. So I know that both of those are radii. And HI is 11. And KI, so this distance here, is 9.6. How big is KJ? Well, I can figure out the length of HK because I have a right triangle. 11 squared plus 9.6 squared equals C squared. So that would be 213.16. Take the square root. So this distance is 14.6. Okay. So how are we going to figure out we want KJ? That distance right there. Okay, you're going to need this. So two tangent segments of a circle originating from the same point are congruent. Do you remember that from a couple problems ago? Oh no, I lost it. Oh shoot, sorry guys. Let me redraw it. So this was 11. This was 14.6. And this was, no. This was 9.6. And this was 14.6. Okay. So we want to know how big is this? Well, if I have a tangent line that starts from the same point, those two pieces are equal. So this one would also be 11. So this remaining chunk is just 14.6 minus 11. So 3.6. Okay, let's do another one. All right. So XV is 1.5. UX, U to X is 2.5. How big is WV? That's what I want right there. So I have a right triangle. This is A, and this is B, and this is C. So 1.5 squared plus B squared equals 2.5 squared. Subtract 1.5 squared. So 2.5 squared minus 1.5 squared is 4. So B squared is 4. So we take the square root, and we get B is 2. So this length here is 2. But because these are tangent lines, and they start in the same place, this segment is equal to this segment. So this is also 2 up until that point there. And if the whole length is 2.5, then 2.5 minus 2 is just 0.5.